Well, folks, yep, this is plasma. This is one lithium-ion battery. You may know that nominal voltage is 3.7 volts, and if we hook it up to a DC motor, it will spin like that. These are two lithium-ion batteries. If we connect two of them in series, we will get 3.7 plus 3.7, which is 7.4 volts. If we connect a DC motor to two of them, it will spin faster because we have more voltage. If we have 10 of them, of course, we simply multiply 3.7 by 10 and we get 37 volts. And that got me thinking into what if we get a lot of these cells and connect them in series to get 220 volts, which are here. Yes, I'm based in Europe, and in Europe we have 220 volts. I happen to have some of these cells. If we do the maths, in theory 60 cells should be enough to provide 220 volts. To test this theory, we will only have to solder all these cells and then connect a kettle, which by the way is rated at 2000 watts. Which is quite a lot, but there is only one way to find out what will happen. And before I start soldering all these cells together, we need to check if they are charged. Now, a charged lithium-ion cell will output 4.2 volts. So basically I have to measure all the 60 of them to see if we have 4.2 volts. And this step cannot be skipped, because since the connection is in series, if one cell fails, the whole contraption will fail. That is why I have to check all the 60 cells to be on a safe side. That took some time, but once done we found out that 4 of these cells are dead. And all of these are charged. And with this we arrive to the second part, which is soldering. And before we solder everything, we would have to cut the wire, which will go from here to here, from here to here, from here to here,
one eternity later,
here to here, and from here to here. This is the wire I'm going to use. It's pretty thick, and hopefully it will handle the 220 volts pretty well. The technique I'm going to use may be pretty weird. I simply put the soldering on the table and then add some soldering wire, just like that. When done, I will just cut the necessary length and place it next to the cells. Then we simply repeat the process, and if you guessed correctly, we need 60 wires like that. Looks pretty satisfying, right? And finally we have the 60 cells and 60 cables ready to solder. For these cells to be connected in series, we would have to connect the minus with the plus. And if we connect one of them wrong, some fire can happen. So while soldering these wires, I would have to pay attention to the polarity of the cells, so they are all in series. And just like that, we have the first 20 cells soldered from one side. Now we simply flip it and then solder from another one. The soldering is done, and now we have 3 packs like that, measuring 82 volts each. Now one night passed and I wanna see if we have any voltage drop. Because if we have a voltage drop, that would mean that one of the cells is bad. And we will have to change it before we do the experiment. Good. Great. And perfect. Now I think if we add some tape, that would help stabilize the cells, so they don't move a lot. Yep, this is much more stable. Now let's use some wood to attach the batteries to the wood so I can move it around freely. And also we can add a normal socket, because actually we will get 220 volts which are inside of your socket. Now after all this process we finally have this 220 volts battery with a socket on the top. Basically I can now take it and power my fridge from that socket. But if you know a bit of physics, you know that there is AC and DC current. Here we have DC current, which is direct current with plus and minus. And then here we have AC current, which is alternating current, which means that plus and minus is switching pretty fast. And this is one of the reasons why you may see the light flickering like that. Before we start connecting stuff to this socket, let's see that we have 220 volts or a bit more. And we have 247.9 volts. Now if I touch with my fingers here, I think I will get electrocuted, so I will not do that and we can continue with the experiment. So we have the battery, but the question is, what should we test? Because if I plug in a charger from a bike, most probably it will explode because this one is rated for AC current and inside it has a big circuitry. And then if I plug in a kettle, which only has a heating element inside and that's it, this one most probably should work. We have the kettle with some water inside. And then I will be filming with my main camera what will happen, maybe it will explode. And then here we will turn on the thermal camera, because maybe it will get pretty hot. So 3, 2, 1, and we connect the kettle. Of course nothing happens because no power is going into, we have to turn it on. Also I will add a multimeter so we can see what's going on with the voltage. 247.9 volts. Perfect. We have the camera, we have another camera, we have the multimeter, and now the only thing left is to power it on. In 3, 2, 1. First let's turn it on and off again to see what happens. Wet. Nice, and looks like that was enough to burn our kettle. Well, since this is what happened, we can disassemble it and see what burned, because maybe it is an easy fix. Well, and opening the kettle reveals that we don't have much electronics inside, as I said. We only have one light and a system that will shut down the kettle when it's hot. The shutdown system looks like it's here, and then we have this contact here, and another one should be right here, but it melted and there you can see a small dot of melted metal. Well, I was told that this should work, but it didn't, so what we'll do, we will simply connect the heating element directly to our battery. And this is what I came up with. Basically we connect this to the socket, and then we have this cable and this cable which I will be connecting together. A huge spark should happen there, but we will be able to see if these batteries can heat up my water. Again, I have some water inside. Here I lit the camera here so you can see everything. Also the thermal camera is set up and you can see the image here. And if it works, we should hear the normal kettle sound. We do not forget the multimeter to see the voltage. And we can connect. This is connected, and now let's see the spark. Damn! Looks like this is plasma. Well, folks, yep, this is plasma, and this is what you see when a person is welding. Turns out a battery like that can be a portable welder. But we are here to test if it can boil the water, so I should leave the cable connected and we can see if it will boil the water. And also how much charge will it take from these batteries. Now if I hold the cable connected, it should start boiling. Well, looks like everything is working. The water is slowly but surely starting to boil, and that is why I will disconnect it from here for now. Connect the cable here, just like that, and now I can simply connect the socket here. The voltage will drop, but at least we will boil the water. As you can see, we're actually boiling the water. The cells are pretty hot. Some of them are around 90 degrees, which is not good, I think. But, as you can hear, we are boiling the water. I will throw a fan like that, just to be on a safe side, and then we continue boiling. You can see some steam is coming from the kettle, so we can say that we didn't boil the water, but at least we got it hot. It worked with DC current, but we had some cells pop. This one popped, this one is about to pop, and this one is pretty close to popping. Somehow they still output 175 volts, even with a hole like that. These are some temperatures we can see on the cells, and our kettle is actually 64 degrees. Only 35 degrees more to get to the boiling point. So with this we can call this experiment successful. It will be pretty curious to measure the current which is going from this to the kettle, and maybe it's more than 2000 watts that kettle needs. Also, I didn't expect to see some plasma in this experiment, so now we know that we can get plasma from the vape cells. And if you have any other cool idea I can connect to this battery, let me know down below, and of course I will do it in a short format or maybe a full long video. See you in the next one.
Yesterday,